Welcome back to our online class. So today we'll be taking an example on second order ODE of the form a d squared y over dx squared plus b dy dx plus c of y to be equal to a function of x. So this time around it's not going to be f of x equal to 0. So there's going to be a value for uh, f of x. So when you're solving this type of second order ordinary differential equation, where your f of x is not equal to 0, you are going to have two stages to arrive at your y. Your y is always the y of c plus the y of p. Now here y of c is your complementary function. You know, when you first solve it, assuming that this is equal to 0. I hope you got that. Then the y of p, you solve based on a condition. There are conditions for what your y of p is going to be based on what you have here as your f of x. So because I'm having 2 sine 4x here, my y of p will be a cos 4x plus b sine 4x. So let's assume I'm having an exponential here. My y of p is not going to be a cos 4x plus b sine 4x. It's going to be something else. With time we are going to treat them, but we are going to commence with this. So let's get started. Now, solution. I told you we are going to solve this part as if this is equal to 0, because you need two solutions to get your y, unlike when we did that where f of x is equal to 0. So first you solve this as if this is equal to what? Is equal to 0. Now let's rewrite the question. This squared y over dx squared minus 5 dy dx plus 6y equals to sine 4x. Now let's solve for y of c. When I solve for y of c, we said this is equal to 0. Now then I'm going to have m squared minus 5m plus 6 equal to 0. This is very easy to do, and I'm going to look for factors because it's a quadratic equation. If I look for factors that if I multiply them together, I'm going to get positive 6. If I add them, I'm going to get minus 5. Then I'm done. Like you know, that will be m squared minus 2m negative 3m plus 6. Definitely give me that. Now, if I group this into this, I know I'm going to have m into m minus 2, then minus 3 into m minus 2, and that gives me 0. So either m minus 3 or m minus 2 will be equal to 0. Now from here, I know I have m to be equal to 3 and I have m to be equal to 2. So if I'm going to write my y of c, it's not going to be our y this time around, just y of c. That's a complementary function. So that will give me c1 exponential to what? The 3x plus c2e to the what? To the 2x. I've only arrived at the y of c. Now we need to get our y of p. For us to do that, there are conditions. When you have a sine or a cosine function here, either sine or cosine, say this is sine as. Let's assume this is sine as. What your y of p is going to be is cos ax. You're going to have a cos ax plus say b sine ax. Let's assume it's also cos as. You are still going to have the same thing. A cos ax plus b sine ax. Let's assume it's an exponential function. You just bring in k. k of x. Let's assume this is a constant. If it's a constant, your y of p will be equal to k. Y of p will be equal to k. If this is a constant, say 1 or 2, this will be equal to k. If it is, let's say, exponential x, you are going to have k exponential x here. So for this case, I'm going to use this because this is what I'm having as my what? As my f of s. So there are so many cases, and there are also snag cases whereby if what you have as a y of c is also as your f of s, there's you have what to do. But let's proceed. So my y of p, because I'm having sine 4s here, I'm still going to ignore these two for the meantime. I'm going to ignore these two for the meantime. I'll deal with this sine 4s now. So sine 4s, I'm going to have my y of p is going to give me what? A cos 4x plus b what? Sine 4x. Now this is the deal. I have second derivative, I have first derivative. Now this y of p represents this my y here. Take note. So all I need, I'm going to differentiate this the first time and differentiate again the second time. Then I plug it back into this equation, and I'm going to say it's equal to this. It will be equal to what I have here, my f of x. So let's quickly do that. So my yp prime, if I differentiate this, I'm going to have negative 4a sine 4x, right? Plus 4b cos 4x. If I take the second derivative of p, 4 multiply negative 4, I'm going to have negative 16a cos 4x, right? And this time around is going to be negative 16b sine 4x. Very good. Now this is my yp prime prime. I'm going to substitute this value and this value and this third value, my yp, my y prime of p, my y prime prime of p, into the original equation, and it's going to be equal to this. Now I don't have any the coefficient here is 1, so 1 multiplied by everything here will still give me what? Negative 16a cos 4x negative 16b sine 4x. Here I have negative 5 y prime, so my negative 5 is going to multiply what I have here. So negative 5 multiply this, I'm going to have positive 20a sine 4x. Again, negative 5 multiplied is positive, I'm going to have negative 20b cos 4x. Now here I have 6y, so 6 is going to multiply my y of p. I hope you got that. 6 is going to multiply my y of p, so I'm going to have plus 6a cos 4x plus 6b sine of 4x, and everything will be equal to what? 2 sine 4x. Very good. So equal to 2 sine 4x. So if I look at what I have here, by the time I group everything here, negative 16a cos 4x, and I have positive 6a cos 4x. That will give me what? Negative 10a cos 4x. So I've been able to take this and this. Again, negative 16b sine 4x plus 6b sine 4x, that is this and this. That will give me what? Negative 10b sine 4x. At the same time, I have this, right? Plus 20a sine 4x minus 20b, let me write it here, cos 4x. Everything will be equal to what? 2 sine 4x. Very good. Now, this is the deal. We are going to look at what you have at the right hand side. We are going to compare it to what you have at the left hand side. I have sine 4x here, right? I also have sine 4x, but I don't have anything like cos 4x at the right hand side. So it means my negative 10a cos 4x and negative 20b cos 4x will be equal to 0 on the right hand side. So you compare both sides. So I'm going to write this as, let me write this first, 20a sine 4x, then write this, negative 10b sine 4x equal to what? 2 sine 4x. You can see where we brought in the 2. Now this side, negative 10a cos 4x and negative 20b cos 4x will be equal to what? 0, because I don't have any value of cosine at my right hand side. From here, I can compare coefficients, or I can compare values. Sine 4x and sine 4x, if I bring out sine 4x from these two, if I factor out sine 4x, it will cancel sine 4x. So what I have here is 20a minus 10b equals 2. And for this, I assume that cos 4x and cos 4x, I have 0 cos 4x. So cancel out each other. So I have negative 10a minus 20b equal to 0. So I can solve this simultaneous equation. So if I want to eliminate b, I can multiply this equation 1 by 2. So that I'm going to have, let me do that here. I'm going to have 40a minus 20b to be equal to 4, and negative 10a minus 20b to be equal to 0. So I'm going to subtract, let's call this equation 3, and let's call this equation 4. I'm going to subtract this 4 from 3 if I put minus here. So 40 minus 10, I'm going to have 50a, right? If I put minus here, it's going to be positive, to be equal to 4. If I divide both sides by 50, now my a is going to be what? 4 here, 2 in 4, I have 2. 2 in 50, I have 25. My a is 2 over 25. Very good. Now, I will substitute this in any of these two to get my b. Okay, let's do that somewhere else. Let's write 20a, or let's do this. This look very easy. Minus 10a minus 20b. Let's do it here. Negative 10a, negative 20b equals 0. So, and I said my a is what? 2 over 25. So, negative 10 multiplied by 2 over 25, right? Minus 20b equals 0. So I'm going to have negative 20 over 25 minus 20b to be equal to 0. If I add negative 20 over 25 to both sides, I'm going to have negative 20b to be equal to what? 20 over what? 25. Now I'm going to divide both sides by what? By negative 20. Right? Very good. So that my b will be equal to what? Negative 1 over 25. So I've gotten a and b. Now, you now go back to your y of p and insert that value of a and b inside the y of p. So it means that my y of p here can be written as, my a is what? 2 over 25 cos sine of 4x minus 1 over 25 sine of 4x. Now, the general solution is y equals to y of c plus y of p. Now come back. This is our y of c, right? And this is our y of p. We now write both equations together so that my y can be equal to c1 exponential to the 3x plus c2 exponential to the 2x plus everything I have here, plus 2 over 25 cosine of 4x minus 1 over 25 sine of 4x. And that is the answer. Thank you very much. Remember, the deal is that you must be happy, I must be happy, we must be happy. So endeavor to like, comment, subscribe, and share. Thank you.